Hello my dear children, welcome to the mathematics class. Today we are going to discuss permutations and combinations. In this chapter we have discussed in the previous class exercise 7.1 and its concepts and its applications of the concepts of exercise 7.1. I hope you have learnt well. I hope you understood well. Haven't you, my dear children? Right. Now come to the exercise 7.2 concepts. In this class, we are going to discuss the concepts of exercise 7.2. Okay, my dear children, are you ready to listen the class? Right. Now come to the definition, permutation. Actually, what is meant by a permutation? A permutation is an arrangement in a definite order of a number of objects taken some or all at a time. Okay, my dear children, this is nothing but mathematical word. Permutation means arrangement. Simply to say, permutation means arrangement. Suppose to understand this definition well, let us take an example. Suppose four letters are there. We are given four letters. How many two letters can be formed? How many two letters can be formed by using these four letters? In the previous exercise, we have used principle of multiplication, fundamental principle of multiplication. So two letters are required. First blank can be filled by any one of these four letters, and the second blank can be filled by 12 two letter words can be formed. Two letters. Suppose I will write what are the 12 arrangements. So two letter permutations, two letter arrangements, AB, AC, AD. Okay, my children, out of these four letters I have chosen only two letters. Next BC, BD. Next CD. Okay, my children, these are one kind of arrangement. If we write in the reverse order, BA, CA, ABACAD, DA, CB, DB, DC. Now count how many arrangements, how many permutations we have got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Without writing this list of arrangements, in the previous exercise we counted without writing this list by using the principle of multiplication, fundamental principle of multiplication. Okay, my children, understood this point? So how many arrangements are formed, how many permutations are formed? Two letter words, 12. Understood this point, my children? Suppose three letter words. The words may have meaning or may not have a meaning. Okay, my children, three letter permutations. Can you find without writing that list, how many three letter arrangements can be formed? Just like here, use fundamental principle of multiplication. Three blanks. We are taking three blanks here. Here we are assuming that repetition is not allowed. Okay, my children? Right. So first blank can be filled by any one of these four letters, and second blank can be filled by any one of the remaining three letters, and the third blank can be filled by any one of the remaining two letters. How many? 24. So 24 words can be formed, 24 permutations. We get 24 permutations by using the 4 letters. How many 3-letter permutations are formed? 24. Okay, my children, understood? Like this, ABC, ABC. Next, ABD. Next, ACD. Okay, my children. Next, BCD. Okay, my children, understood this line. If you rearrange these 3 letters, how can you get BAC, CAB? Yes or no, my children? Next, similarly, this also BAD, DAB. Okay, my children. Next, CAD, DAC. Next, CBD, CDB. With AB. Next to AC, we go over it like this. How many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Next, 24. We have to get it 24. We have missed some letters. A, C, AB, ABC we have taken. Next, we have taken ABD. Next, BCD. And any more arrangements are there, my dear children? DAB. These letters, see here arrangements. How many can we get any more arrangements? ABC, ACB, isn't it, my children? ABC, ACB. Next, similarly, BAC, BCA. Next, CAB, CBA. Okay, my children. Similarly, arrange these 3 letters. ABD, ADB. Okay, my children. ADB. Next, BDA. This one, DBA. Understood these arrangements, my children? Similarly, we can write 3 more arrangements. Here also we get 3 more. Total 1, 2, 3, 4, 5, 6. Let us write that arrangements also. CAD, CDA. Okay, my children. CAD. Next, DCA, DCA. Next, ADC. Similarly, let us write these BDC. Okay, my children. BDC. Next, DBC, DCB. How many arrangements we got? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6 fours are 24. So, without writing this list, it is a time consuming. Yes or no, my children? If you want to write all this list, it is a time consuming factor. But without writing this list of arrangements, we found in the previous exercise with the help of fundamental principle of multiplication. Understood the use of Importance of fundamental principle of multiplication, my dear children. Right. So what is meant by permutation? Arrangements. Here how many arrangements we got? 12 arrangements. Here 24 arrangements. Understood this point, my dear children? Right. Now come to the second point. In the first point, we have defined permutations. Now come to the second point. Permutations, when all the objects are distinct. How many permutations can be found? How many arrangements we get? With the help of this second point, we can find how many permutations are possible. See, the number of permutations of n different objects taken or at a time when 0 less than or equal to n and the objects do not repeat is n into n minus 1 into n minus 2 into and so on, n minus or plus 1. Okay, but this product denotes the number of permutations of n different objects taken or at a time. For example, in the previous examples, in the first question, how many letters are taken? 4 letters, namely A, B, C, D. Yes or no, my children? In the first example. And how many letters are arranged? 2 letter words. Okay, my children, 2. So 2. R is equal to here 2. So we got 4 into 3, 12. Okay, my children, by using the principle of multiplication. Here also we use the same formula, same rule, principle of multiplication. So this product is denoted by NPR, total number of objects here, and how many objects are arranged here. Okay, my children, this NPR is equal to n into n minus 1 into n minus 2 into n minus 3 into and so on, n minus r plus 1. Okay, my children. Now let us find how you got this number of permutations. You know how many objects are taken to arrange R objects. So you have to fill the R blanks. 1, 2, 3, 4, 5 and so on. R blanks. Okay, my children. The first blank can be filled by any one of these n objects. Yes or no, my children? N. The first blank is filled. Here total n events are there. N jobs. N operations are there. We are performing n R objects one after the another. After one operation is completed, after the one operation is performed, we complete the second operation. We perform the second operation. After the second operation is performed, we go to the third operation. Okay, my children, understood this point? So first operation is over, performed. So how many objects will be left in our hand? N minus 1. Yes or no, my children? So n minus 1. After that, how many objects will be there in our hand to fill this third blank? N minus 2. Yes or no, my children? Next here n minus 3. Yes or no, my children? Here n minus 4, n minus 5 and so on. N minus of r minus 1. Yes or no, my children? N minus one number less than this number. Here 3 is there, here we wrote 2. Here 4 is there, we wrote here 3. One less than this number. Yes or no, my children? So here r is there. So 1 less than r means r minus 1. Yes or no, my children? So n into n minus 1 into n minus 2 into n minus 3 into and so on, n minus, use the distributive property, minus or plus 1. Yes or no, my children? So these many permutations are possible. Understood this point by the children? This number denotes number of permutations of n objects. permutations of n objects and different objects taken or at a time. This product denotes the number of permutations of n different objects taken or at a time. Understood this point, my dear children? Right. For example, 10p3. If you want to find the value of 10p3, okay, my children, what is this number here? Downside number 3. Take 3 blanks. Okay, my children, 3 blanks. Take 3 blanks here. Okay, my children, in between keep into symbol, multiplication symbol. You listen these steps carefully, my children. First, you have to identify, we have to concentrate on this downside number. What is the downside number here? 3. So take 3 blanks, in between write multiplication symbol in this gap. Okay, my children. Now come to this number 10. So start with 10. Start with 10 and write reverse order, descending order in the natural number. 10 after 9, 9 after 8. Okay, my children, that is equal to 10 9s are 90, 98s are 720. Like this we find the value of 10p3. Okay, my children, understood? Right. Suppose if you want to find 8p5, for example, let us take this one. Let us take this example. How do you find the value of 8p5? First we have to concentrate this second number, downside number. What is the downside number here? 5. So take 5 blanks like this. 5 blanks. Take 5 blanks. Okay, my children. In between these blanks, keep into symbol. Understood? This is second step, my children. Right. Now come to this number, first number. Okay, my children. 8. First to write this 8. In the descending order of natural numbers, right? After 8 after what is the number? 7. 7 after 6. 6 after 5. 5 after 4. Now multiply all these 5 numbers. Then you get the value of 8p5. Understood, my dear children, how to find these notations, the value of these notations? Okay, my dear children. Suppose if you want to find 7p2, how do you find? First step, how many blanks should be taken? 2 blanks. In between symbol, into symbol. In between the blanks, you have to keep into symbol. First you write this number 7. 7 after 6. So 42 is the value of 7p2. Understood this point, my dear children? How to find the value of this notation, NPR? Okay, my dear children? Right. Now come to the next point, third point, factorial notation. This is also important point for this chapter. Okay, my dear children? What is meant by factorial? The symbol, this symbol is read as factorial n or n factorial. Either this notation or this one. This is not angle n. Okay, my children, don't be confused here. This is not angle n. N factorial or factorial n, or like this. Okay, my children, represents the product of first n natural numbers. That is, we define here factorial n or n factorial as 1 into 2 into 3 into and so on, n minus 2 into n minus 1 into n. From 1 to n natural numbers, the product of first to n natural numbers. But in practice, we take this n factor, this step, n factorial is equal to, I wrote in the reverse order. See here, n into n minus 1 into n minus 2 into, before this number n minus 3, before this number n minus 4, and so on. 5 into 4 into 3 into 2 into 1. In practice, in solving the problems in this exercise, generally we take this step. Okay, my children, in solving the questions, we take this step 1. N factorial is equal to, starting from this number n to number 1. In the descending order, we write the natural numbers and we find the product of that n numbers. Understood this point, my children? Factorial n. Right. Clearly, for a natural number n, n factorial is equal to n into n minus 1 factorial. So, if you want to stop by this product, suppose if you want to stop by this product, immediately you have to keep here factorial symbol. Suppose if you want to stop this product by this symbol, by this factor, immediately you have to keep here factorial symbol. Understood this point, my children? Similarly, if you want to stop this product by this number, immediately after this number we have to keep factorial symbol. Understood this point, my children? And so on. But for our convenience, we take 0 factorial value is equal to 1 and 1 factorial value is also 1. Okay, my children, remember all these points. Okay, my children. For example, if you want to find factorial 5 factorial, value of 5 factorial, we start with the 5 and we write the natural numbers in the descending order from starting from 5. So 5 into 4 into 3 into 2 into 1. So the product of all these 5 numbers, that is equal to 120. This number is the value of n factorial, 5 factorial. Understood this point, my children? Suppose if we want to find the value of 3 factorial, starting from the number 3, and we write the natural numbers in the descending order starting from this number. So 3 into 2 into 1. Understood this step, my children? After writing this step, we have to find the product of these 3 numbers. What we will get here? 6. So 3 factorial is equal to 6. The value of 3 factorial is equal to 6. I hope you understood the definition of n factorial. Yes or no, my children? Right. Now come to the exercise 7.2 sums. Okay, my children. The concepts of exercise 7.2 over. Okay, my children. What are the points we have discussed? Let us recall that points. The first point is definition of permutations. What is meant by permutations? Permutations means arrangements of objects. Simply to say, permutation means it is a mathematical term. Okay, my children. Next we discuss the number of permutations of n different objects taken or objects at a time. Then NPR, it is denoted by, symbolically it is denoted by NPR, and we found the value of NPR. Yes or no, my children? Right. Next point is factorial n factorial. We have discussed that point also. The product of first n natural numbers. Okay, my children? By using these points, we solve the problems in the exercise 7.2. See page number 140 in the textbook. Okay, my children? Right. Come to the question number 1. Evaluate 8 factorial. Okay, my children? We have to find the value of 8 factorial. Now come to the solution. 8 factorial is equal to, how do you write this one? 8 factorial. 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Yes or no, my children? 8 factorial means 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Starting from this number to the number 1 in the descending order. We write the natural numbers starting from this number to 1. Okay, my children, understood this point? Right. Now find the product of all these 8 numbers. What you get? For 40,320. Yes or no, my children? 40,320. This is the value of 8 factorial. Okay, my children, understood? Right. Now come to the second question. Evaluate 4 factorial minus 3 factorial. Okay, my children, don't be confused here, my children. 4 factorial minus 3 factorial is equal to 1 factorial. Don't subtract that numbers like this. Okay, my children, we have to find the 4 factorial value separately, and we have to find the 3 factorial value separately, and we find the difference of the numbers. Okay, my children, how do you find 4 factorial value? 4 into 3 into 2 into 1 minus, understood this value, my children? 4 factorial, right? Minus, how do you write 3 factorial? How do you find 3 into 2 into 1? Okay, my children, now let us find the value of 4 factorial. 4 3s are 12, 12 2s are 24, minus 3 2s are 6, 6 1s are 6. So the value of 4 factorial minus 3 factorial is equal to 18, not 1 factorial. Okay, my children, understood this point? Right. Now come to the second question. Is 3 factorial plus 4 factorial is equal to 7 factorial? We have to check whether this value is equal to this value or not. Okay, my children? Right. Come to the LHS. What is LHS? 3 factorial plus 4 factorial. Let us find the value of LHS. What is the value of 3 factorial? 6. Okay, my children, we have already found in the previous question. What is the value of 4 factorial? 24. Then what you get? 30. 3 factorial plus 4 factorial is equal to 30. Okay, my children. Right. Now come to the RHS. 7 factorial. How do you find 7 factorial? 7 into, starting from this number, and we write the natural numbers in the descending order starting from this number. Okay, my children. So 7 into, 6 into, 5 into, 4 into, 3 into, 2 into 1. What is the value? 5040. By multiplying all these 7 numbers, we get 5040. Whereas LHS is 30 only, but RHS is 5040. Are these two numbers equal? No. Therefore, LHS is not equal to RHS. Therefore, 3 factorial plus 4 factorial is not equal to 7 factorial. Understood this point, my children? Right. Now come to the question number 3. Compute 8 factorial by 6 factorial into 2 factorial. Okay, my children, understood this question? Right. Come to the solution part. 8 factorial by 6 factorial into 2 factorial. Come to the numerator. What is there in the numerator? 8 factorial. How do you find 8 factorial? We start from this number, we write the natural numbers starting from this number to 1 in the descending order. Yes or no, my children? So 8 into, 7 into, 6 into, 5 into, 4 into, 3 into, 2 into 1. Whole divided by. Understood the numerator part, my children? Right. Come to the denominator. 6 factorial. How do you write to? How do you find the value of 6 factorial? We start from the 6 and we write the natural numbers in the descending order starting from 6 to 1. Okay, my children. So 6 into, 5 into, 4 into, 3 into, 2 into 1. Okay, my children. Understood this part? This is the value of expansion of 6 factorial. Now come to the 2 factorial. How do you find 2 factorial? Starting from 2 and to 1, 2 to 1. Understood this one also, my children? Right. Now we strike out. We simplify this number. Here 6 gets cancelled. 5, 5, 4, 4, 3, 3, 2, 2. Here 2 1 times, 2 4 times. Finally what you get? 4 7s are 28. Okay, my children, understood? Now come to the question number 4. Question number 4. If 1 by 6 factorial plus 1 by 7 factorial is equal to x by 8 factorial, find the value of x. Understood this question, my dear children? Right. Come to the solution part. Given 1 by 6 factorial plus 1 by 7 factorial is equal to x by 8 factorial. Okay, my dear children, I wrote the given equation as it is. In these three numbers, which is a least number 6. So we have to write this number also 6 factorial, this number also 6 factorial. Okay, my dear children? Right. So 1 by 6 factorial. How can you write this one? 7 factorial. 7 factorial can be written as 7 into 6 factorial. Yes or no, my dear children? Previously, I told you, if you want to stop by second number, you have to keep a factorial symbol there. Okay, my dear children? Right. Is equal to x by, here 8 factorial is there. So 8 into 7 into, I want to stop by this number. So immediately we have to keep a factorial symbol. Okay, my dear children, understood this point? Right. Here 1 by 6 factorial is common factor. From these two numbers we can take 1 by 6 factorial common. Then what we get? 1 by 7. 1 plus 1 by 7 is equal to, here x by 56 into 6 factorial. Okay, my children? 7 8s are 56 into 6 factorial. Here denominators gets cancelled. Okay, my children? Understood? Right. This implies, take the LCM, what you get? 7 plus 1, 8 by 7 is equal to x by 56. Okay, my children? Right. Here 7 1, so 7 8 times. This implies 8 is equal to x by 8. Now cross multiplication. We transform this by 8 to this number. It becomes 8 into 8. That is equal to 64. This is the value of x. Understood, my dear children? Right. Now come to the question number 5. In this question number 5, there are two parts. Here I am explaining the first part of this question. Please try the second part of this question. Same as this question. Okay, my dear children, follow the same steps to find the value of the second question. Okay, my dear children. Evaluate n factorial by n minus r factorial, where n is equal to 6, comma r is equal to 2. Understood this question, my dear children? We have to find the value of this number, where n is equal to 6 and r is equal to 2. Now come to the solution. What is given? N is equal to 6 and r is equal to 2. Now let us take this expression n factorial by n minus r factorial is equal to, what is n here? 6. 6 factorial by 6 minus 2. Okay, my children, in this expression I am substituting n and r values. Okay, my children. Then in the numerator, what is there? 6 factorial. How do you find 6 factorial? 6 into 5 into 4 into 3 into 2 into 1 whole divided by. Understood this numerator, my children? Right. Come to the denominator. 6 minus 2. What will get? 4. 4 factorial. Okay, my children? In the denominator, 4 factorial. This is not 6 factorial minus 2 factorial, my children. 6 minus 2 factorial. Okay, my children? Then we can write 4 factorial. Here in the denominator, 4 factorial is there. Let us evaluate 4 factorial. 6 into 5 into 4 into 3 into 2 into 1 by. How do you evaluate 4 factorial? 4 into 3 into 2 into 1. Understood this denominator, my children? Right. 4 4 gets cancelled, 3 3 gets cancelled, 2 2 gets cancelled. Finally, what you get? 6 5 30. This is the value of n factorial by n minus r factorial when n is equal to 6 and r is equal to 2. Okay, my children. Do you evaluate the second part of this question, my children? Same steps. Okay, my children, will you try yourself? Right.